Now, as we said in the chapter on UV layout, if you want to get your work out of ZBrush, you have to have UV coordinates and you have to extract maps. So your geometry, you can export quite simply. You just step down to your lowest subdivision level and then go to export, and you can export an OBJ file. Texture maps, displacement maps, etc., those require a couple more steps. To get all your sculpting and painting out of ZBrush, your painting you want to export as a texture map. So we'll step up to our highest subdivision level and we'll begin with that. How do I get this poly paint out of ZBrush? Now remember, this model has UV coordinates assigned to it. If I go to UV map and morph UV, you'll see that we actually have a pretty clean UV layout that was created with UV master. Let's solo that and focus so we can see it. So that's a pretty nice clean UV layout. So I'm going to turn off morph UV, turn solo back off. I want to get this poly paint baked down into that UV map as a texture map. So to do so, I'm going to go to texture map, and here we have a submenu called create. If I click create, I can select new from poly paint. So if I click new from poly paint, it's going to generate this texture, but it's set it to 1K. That's 1024 by 1024, which we don't want. So I'm going to go back to UV map and to do that, I click clone texture, and that clones it out of this texture swatch and places it in the main texture palette here. And from here, I'm able to click export, and then I can save it as a PSD file. You could also save as a JPEG, a PNG, or a TIFF file. So that's all you need to do to get a texture map out. It's actually quite simple. Next, let's talk about a normal map. Normal mapping will be familiar to those of you that are very interested in real time, like gaming. Normal mapping is a way to represent all the sculptural detail of your model without having to have an extremely high resolution mesh. If we go to the subtool menu and turn off poly paint on the head here, and go to our texture map and turn off the texture, we can actually see the sculptural detail in this character, and there's quite a bit of little fine details on there. A normal map is going to capture those details, and then when you render it in Maya or in your game engine, it will create the illusion of there being a very, very detailed surface. The only thing that a normal map cannot do is it cannot change the overall silhouette of your model. So you need to make sure that the model, the lowest resolution, is built in such a way that the perimeter, the silhouette, looks good. It doesn't look too faceted, because a normal map is only going to create the illusion of detail here in the detail of the head, not the perimeter, because it doesn't actually change the geometry. So let's look at how we create a normal map. I step down to my lowest subdivision level and I go to the normal map menu here. I'll leave it at tangent. I can turn on adaptive. This just changes the methodology by which the map is created. Sometimes adaptive will give you artifacts, sometimes turning it off gets rid of them. Usually I turn it on. The only reason to turn it off, I think, is if it's taking too long or if it just doesn't work accurately. Smooth UV will smooth the UV border, and smooth normals smooths the edge normals. So it's quite simple. You do have the option to flip the RG and B channels. Now this is going to be entirely dependent on where you're rendering the map. If you're doing it in Maya, these settings are fine. But in some game engines, you might need to change this, so there will be a technical person who can tell you if these need to be changed. So I will click now Create Normal Map. And what it's going to do, it's going to process the adaptive rays. It's basically ray casting from the center of the model, and those rays will intersect with either the high resolution mesh or the low resolution mesh. Whatever one it intersects with first, it makes a note of that value, and then it eventually hits the other mesh. So it's going to record for each pixel the difference between the high res and the low res model. That's why sometimes normal maps and displacement maps are called difference maps. Essentially, these millions and millions of rays are calculating for each pixel on the surface of the model whether or not that point needs to be pushed in or pushed out. So it'll just take a couple more moments before it's finished generating that map. And there we go. Your normal map is applied here in this texture swatch. So you can see we've got a nice sort of relief map there. Now, again, if I want to export this manually, I click Clone Normal Map, and that places it in the texture menu here. And from here, I can export that map. Now, let's take a look at displacement mapping. I'm going to open up Displacement Map, and I'm going to set it to DP subpix 2, Smooth UV, Flip V, because typically the Maya texture space is flipped vertically from Zbrush, so we need to flip it. And I'll set 3 channels. Now you can set it to 32-bit, but we'll talk more about that in a moment when we do the multi-map exporter. This defaults to a 16-bit map. We do set it to 3 channels, even though it's shades of black and white. The 3 channels gives us more bit depth. 32-bit will bake in the object scale and give us a super accurate map, but that's more useful to us when we're using the Z plugin multi-map exporter. So we'll talk about that there. So now I've got 2 buttons. I can create the displacement map here, or I can create and export the map. If I click that, it's going to ask me where it wants to save the map, and then I can tell it where to save and then create the map. Now typically I select DP subpix 2. If this gives you artifacts or it doesn't work well, I'll set this down to 0 and I'll turn on adaptive. I have found that adaptive mode tends to take longer, so usually I go to DP subpix 2. And what this is, adaptive mode, when it's generating the displacement map, it will adaptively subdivide the areas with more detail to give you a super crisp map. But it's working just in those areas that have high detail. DP subpix is sort of a global setting, so that will subdivide the model 2 more times in memory to give you a very high frequency, high quality map. So once we've got those set, I will click Create Displacement Map. And once again, it will cast rays. It's going to cast rays from the origin out, hitting the shell of the model. If it hits the low resolution first, if it hits the first subdivision level first, because imagine that in ZBrush right now, it's got the highest subdivision level and the lowest subdivision level sitting on top of each other in space. If it hits the low res first and then it hits the high res second, it knows that it has to record a lighter value there because the mesh is pushing out. If it hits the high res first and then hits the low res, it's going to put a dark value in there because that means that the high res is pushing in from where the original model is. So here's our displacement map. And once again, we'll click Clone Displacement. It places it in the Alpha menu, and from here, we can export it. Now, what's kind of nice is you'll notice that this displacement map is actually displaying as a bump map on the surface, so we can actually get a clear picture of how it's going to look. It's a nice way of troubleshooting or just testing to make sure that all the detail is in there, because we're still on the lowest subdivision level right now, but there's all the detail in my map. Now, if we want to preview our mesh displacement as actual displacement, you can turn on the mode button here, and that shows it as an actual displaced mesh. If I turn it off, it's simply displaying it as a bump map on the lowest subdivision level. So we've seen now how to do normal maps and displacement maps, and how to do texture maps. Now, if I have a texture map in the texture map slot, I have a displacement map in the displacement map slot, and I have a normal map in the normal map slot, I could take advantage of Go Z. What Go Z will do is, if I click Go Z, or click All, or click Visible, it will take all the subtools, or the visible subtools, whichever one I press, and it will automatically export them and load them up in a Go Z compatible application. So what I have on my system is Maya. So if I click Visible, it will take this mesh, export it out as an OBJ. It will export each map that I have loaded up into one of these swatches. So it'll export the texture map, it will export the displacement map, and it will export the normal map, and it will automatically set up the shader in Maya so those are ready to render. And all you need to do is press Go Z, All, or Visible to make that work. Now, the first time you run it, it will ask you to browse to a path for a Go Z enabled application. So you can check the Pixelogic website for which ones are being supported. I know it's Cinema 4D, Modo, Maya, 3D Studio Max. All the major 3D applications seem to be supported by Go Z. So let's go ahead and press the visible button, and that will export the visible subtools to Maya and then set it up with the normal map and the color map. So I'll press that now, and then I'll return when we are in Maya. So here Maya has loaded, and it's automatically imported the OBJ file and the associated textures and then set up the shader network to represent those textures. So as I move around the object here, you'll see that the normal map is displaying on the object. We've got all of our detail visible here. That's because we're using Viewport 2.0 and hardware texturing. So if you turn those on, you'll see that Maya actually automatically creates a shader network for you that figures in your normal map as well as your displacement map. It also has the color map automatically set up. So these are all very, very handy, and it's a nice way to just streamline getting from Zbrush into Maya. So that is GoZ, which you're going to find right here. And that's going to work for all the major 3D applications. You'll just need the first time that you run it to browse to the path of the application that you want to be using. So now that we've seen how to manually create each map, I'd like to talk to you about a plugin that is extremely useful that allows us to do several things that we cannot do when we're just extracting maps using the displacement map and the normal map options here. And that's called Multimap Exporter. I'm going to go to the Z plugin menu. We'll tear it off to the side of the screen, and I'll go to Multimap Exporter here. And here you see that we've got a selection of map types that can be selected. So I'm going to turn on displacement, normal, texture from polypaint, ambient occlusion, cavity, and export mesh. Now vector displacement maps are created in ZBrush. They allow you to displace around angles. So instead of just displacing in or out, vector allows you to go around 90-degree angles and spirals. If you open Vector Displacement Map here under the Tool menu, you have the option to run the diagnostic. What you need to do is run the diagnostic, and that creates a file for you that you will then have to test in your own renderer. So vector displacement maps don't have a sort of standardized setting yet. So each renderer will handle them a little bit differently. So to determine what your settings need to be, you need to run this diagnostic and then render the resulting file in your 3D application. And then that will give you the settings that you need for vector displacement map. So we're going to focus in on the other map types: standard displacement, normal, texture from polypaint, ambient occlusion, cavity, and then exporting the mesh. So I can turn on subtools, and this will allow me to export all my maps for all my visible subtools. Now, if my subtools all have UVs that sit within the same UV region, I can turn on merge maps, and that will merge all the subtool displacements into a single map, and that can be really, really useful. For example, if I'm working on a costume where the shirt and the pants, the UVs for both of them occupy 0 to 1 texture space, I can turn on merge maps, and then I can just extract both of those maps from each subtool and then merge them together automatically. We can set our map size here. Right now it defaults to 2K, but you can set it all the way up to 8K. I'm going to set it to 4K. There we go. We have these preset buttons here that you can press to speed up selection. Map border is the overpaint border. I just leave that at 4. Flip V, of course, flips vertically, and recalculating the smooth UVs. If you're getting arrows along the seams, if you recalculate your smooth UVs at the highest subdivision level, that can help if you're getting artifacts along the seams. Now we open up render options. File name. This allows us to change the type of naming that we have for each one of our displacement maps. Now, Multimap Exporter has one very huge benefit over extracting your maps into the tool menu, and that is that it will work with UDIMs. It will work with models that have UVs outside of 0 to 1 texture space. So if you are working with UDIMs, it is possible to extract your displacements using Multimap Exporter. Also, if you've got a model that is using UDIMs, you can use HD geometry levels, and ZBrush will extract your color and your displacement using those multiple UDIMs and it will figure in the HD geometry subdivision levels. So it's an actual really nice way of getting around the limitation of a single UDIM in ZBrush and some polygon count limitations. You can subdivide up to 1 billion polygons with Geometry HD. If you watch the HD geometry video, you'll see that in action. And then if you have the UVs for your base model spread out across multiple UDIMs, you can take full advantage of all that texture resolution, because 1 billion polygons is not going to create a particularly good displacement map in 4K. So you really do want to have a model that's taking advantage of UDIMs, and you need to extract using Multimap Exporter if you want to get displacement or color or any other maps outside of the standard 1001 or 0 to 1 texture space. Next we have Switch MT. Now if you have imported a model to sculpt on, the process of sculpting on it is going to change the level 1 subdivision shape. Switch MT allows us to store a morph target of the model before we start sculpting on it, and then Switch MT, if you turn that on, it will switch back to that original shape before it generates the displacements. So to show you what I mean by that, if I were to bring in a polysphere, and let's say that this polysphere is somewhere being set up in Maya for rendering, and it's been passed to me and they say, would you sculpt something on this that we can displace? So I add subdivision levels and I do some sculpting here. And I say, okay, well, here we go. Step down to the lowest subdivision level and generate the displacement map. Well, the problem is this displacement map is going to be applied to this polysphere. Now you can see that level 1 is completely different. The shape of level 1 is completely different between these two levels. So what I need to do is step down to level 1, store a morph target, add some subdivision levels, do my sculpting, then step back down to my lowest subdivision level, and then switch the morph target. That's what this button does, Switch MT. That means that it's going to generate a displacement map between this shape and then the shape at the highest subdivision level. So the values are going to be accurate to displace this form from this base model. So that's very, very important, because if you don't switch back to your original morph target and you try and apply those displacements to a slightly perturbed mesh, your displacement values are not going to be accurate. So keep that in mind. If you don't remember to store a morph target, you can always just import your level 1 OBJ back into level 1 and then generate your displacements. Because as long as you don't step back up your subdivision levels, it's not going to change the sculpture at the higher subdivision levels. So step down to level 1, re-import your original mesh, and then generate your maps. Estimate time and reset all settings. Estimate time is not really particularly accurate in my experience, and reset all settings will reset your settings to the default. Now we have the settings per map. So if I go to displacement map, I can set what subdivision level I extract my map from. Now that can be handy, because if I were to extract my displacement, and I'm going to go ahead and turn off the displacement map here, and I'm going to go to texture map and turn that off. Go to polypaint and turn polypaint back on. So if I extract a displacement map from here, the difference between level 1 and level 5 is vast. That's a displacement map. However, if I step down 2 subdivision levels and I extract a map from between level 3 and level 5, that's mostly high frequency detail. So if I extract a displacement map from level 3, that's going to be more like a bump map. It's not going to carry so much of the big shapes. It's going to carry more of the fine detail. So it can be desirable sometimes to change your subdivision level from which you extract the map. Again, I'll set DP subpix to 2, turn off adaptive, smooth UV, 3 channels. Now, when you're using a 16-bit map, which is what this is, it doesn't have object scale baked in. Your look dev artist, or you, if you're the one rendering, you're going to have to adjust your alpha gain to get your displacement settings correct. If we set it to 32-bit and then turn the midpoint down to black, that's going to create a 32-bit displacement map. And I often turn on EXR because that's typically what I'm using at work. This will create a 32-bit displacement map centered on black rather than gray. Now what this means is the look dev artist can bring that displacement in and it will render perfectly on the first go. They don't have to tweak any of the volume settings or the intensity settings on the map to get an accurate displacement. Scale and intensity, and I leave these as they are, and I usually don't mess with my 16-bit scale. So those are my settings for displacement. We'll leave those as they are, close out displacement, and then we'll open up normal map. Normal map again, tangent adaptive, smooth UV, smooth normals. The rest of these buttons, you will know if you need to change them because someone will tell you, or it will be in the documentation for whatever your renderer is. For Maya, these settings should be fine. Ambient occlusion map. This is going to pull the ambient occlusion settings from the masking menu. So if I go to Tool, Masking, Mask by Ambient Occlusion, I can adjust these settings here, or I can adjust them here. Now Cavity map will also pull its settings from Mask by Cavity. So here, if I want to create a cavity map, I turn up my intensity, and then I make the curve look something like this. Then I click Mask by Cavity, and this gives me a really nice mask that just gets down into all the recesses. It creates a nice black and white mask that will be quite useful when you're look dabbing if you want to be able to mask out the recesses or the high points. A cavity mask allows you to do that. Cavity map will just create that mask as a map. So cavity blur, cavity intensity are here. You can use the same curve for all the subtools if you're going to be generating displacements from multiple subtools at the same time. You can make it a 16-bit map, and you can use colors. You can use the main and secondary colors when you're creating the map by clicking here, and that'll utilize these colors. Now mesh export just gives you the settings for exporting your mesh. We want it set to tries, and we want groups turned on. That'll export the polygroups with the mesh. We also turn on merge. That merges your UVs when you export the mesh. And we can also set the subdivision level that is exported. Now if I want to save these presets to share with other artists, I can save them using this button here. Now when I'm ready to generate my maps, I simply click Create All Maps, and it will generate each one of these maps and save them in the location that I specify. So if I click Create All Maps, it's going to ask me where to store them. I can browse to a location to store them. Let's go to our project files, and we'll create a new folder here, and we'll call it Map Exports. And I'll click Save. And it will go through and it will generate each one of those maps, as well as exporting the geometry. Now when it is completed extracting the maps, it'll give you this message here telling you that all maps have been created and exported to the folder that you selected when you clicked Export All Maps, Create All Maps. So that completes this lesson on how to generate maps inside of Zbrush. We've seen how to create them manually under the tool palette, going in and just directly creating displacement, texture map, and normal map. We've also seen how to use the multi-map exporter, which also will generate maps in UDIMs and UV space outside 0 to 1. So if you do have your UVs spread out across multiple UDIMs, then this is definitely the way to go. And the multi-map exporter works fantastic in conjunction with HD geometry. If you have HD subdivision levels and a mesh with UDIMs, you can take full advantage of all that resolution that's available to you here by spreading it out across multiple maps. So I hope you've enjoyed this video. Thanks for watching, and I'll see you in the next.